Hello, my dear students. Hope you are doing well in your flying training and ground training. And the videos that I put up, hope they are helping you. And if you want any suggestions, improvements, etc., you are welcome to comment. It shall be nice. I always believe that there is always a room for improvement. I would like to make it as useful as possible for you all. Otherwise, my effort will be wasted. Right. As you know, we have been working on the numericals in navigation. And today's topic is numericals concerning Machneter. Here are some of the questions that I have given you, 5 questions, different type of questions. Some are very simple based on the concept M is equal to V by C, M is known to you. C calculate with the temperature and V can be calculated. If speed is known to you, you can calculate what will be your Mach number. Only thing I would like to add is that while calculating the ambient temperature for calculation of speed of sound, and which is called the local speed of sound, we use the jet standard atmosphere when we are flying above 36,090 feet. As per ISA, above 11 kilometers, which is 36,090 feet, the aircraft enters into a tropopause and temperatures remain constant at minus 56.5, and so will your speed of sound. At 40,000 feet also, 42,000 feet also, under ISA, temperature will be minus 56.5 and speed of sound will be constant. But in actual practice, the actual atmosphere is called jet standard atmosphere, in which the temperatures keep falling after 36,000 feet also at the same lapse rate, standard lapse rate, which we take 1.98 degrees per 1,000 feet, or for our calculation, we take roughly 2 degrees per 1,000 feet. So as per JSA, at 40,000 feet, the ambient temperature will be plus 15 at the mean sea level, minus a fall of 80 degrees, it will be minus 65 degrees Celsius approx. Then you can add 273. You will get the Kelvin temperature, and 39 to square root of the Kelvin temperature, you will get the local speed of sound under the existing conditions. So unless the examiner specifically tells you that you're flying at 40,000 feet in an ISA atmosphere, by default, take it as a GSA atmosphere. And while calculation of temperatures at 42,000 feet, it is 2 degrees into the thousands of feet, even beyond 36,090 feet. Rest you will find are then fairly simple numericals in Machmeter. Very difficult, complicated equipment, but numericals are fairly simple. Some such numericals which are asked are that if you're flying at 25,000 feet at Mach 0.75 and you have a TS of 410 knots, what will be your TS at 0.77, or what will be the increase? Okay. M is equal to V by C at 0.75. Your speed of sound will be 410 divided by 0.75, which will be 547. So if the aircraft is at Mach 1, speed of sound and TS both will be 547. So Mach 1 is 547 and Mach 0.02 will be 547 into 0.02, that is 11 knots. Or second method is at 0.75, the TS is 410. At Mach 1, it will be 410 by 0.75, and at 0.77, unitary method multiply by 0.77. So either you can take this difference and solve this question. In both cases, you will get a new TS of 421 knots. Well, you have the calculator with you. With the same, then you can do it on the calculator also. Find out the speed, true wave speed at 0.75 and 0.77, and that will be the difference. Question number 2. Okay. The question number 1, one of the choices is why increase the Mach number? Well, leave it to the examiner. If he says increase it, and give him the answer. Question number 2 is, if the Mach number increases by 0.06, what will be the new TS? Is similar to question number 1 with a little bit of variation. Question number 3, ambient temperature is given to you. And he says, find out the true wave speed, find out the local speed, the value of C. Temperature is given to you, 39 to square root of the temperature. But remember, this temperature is in Kelvin. So don't forget to put this value in Kelvin and you will get the local speed of sound. In question number 4, use the equation that is equal to sat into 1 plus 0.2 km square. Ignore k if value not given, and solve this question in Kelvin values. Okay. This question is at 33,000 feet, that is given to you. So first convert it into Kelvin and then find out the still air temperature. And once you find out the still air temperature, you know the altitude at 30,000 feet. This is the actual still air temperature. What should be the ISA temperature at 30,000? And you know how to calculate deviation. T ambient minus T ISA gives you the ISA deviation. And once you know the ISA deviation, he could further ask you, give me the density altitude or the true altitude. In both these numericals which you had done earlier, we need ISA deviation. 5 is also fairly simple. He wants the ISA tat in degrees Celsius. So find out the temperature ISA. That will be your ambient temperature under ISA since there is no deviation. And that will be your still air temperature. And then find out tat by using the same formula which we have done in question number 4. Right? So try these questions on your own. I am trying to give you a hint, but not spoon feeding you and not doing the entire question with you. If you don't put in your effort, okay, then there's hardly any chance of a success. Like there is a very famous saying that if you want to go to heaven, you have to die. You can't go to heaven without dying, that somebody else dies and you go to heaven. And here the word dying means put in your effort. That I want this lessons. Put in the effort, and in the years to come, you will not only know this everything yourself, you will be able to teach others also. And I shall look forward to that. You are reaching that level where you are so good that you can start teaching others also. And never let this get into your head moment you are doing slightly well. There will be always something else to learn. Okay, I have decades of experience in aviation, but I'm still learning, to be frank with you. Next, are the few questions on magnetism and compasses. Question number 1 is that same good old formula, deviation on a heading theta. Here, your theta is 210. This is my theta. A plus B sine theta in bracket. Value of B, C, is it plus or minus? Sine theta, C is plus or minus. And solve this. A plus B sine theta plus C cosine theta. Similarly, A could also be plus or minus. Okay. Like in this question, you see A value is minus. Question number 2 is a variation of question number 1. Okay. And fairly simple. Anyone who is worth his salt in algebra, maths, will be able to solve it. And little bit of trigonometry, we need to know sine theta, cosine theta. Next is question number 3. Question number 3 wants you to find out coefficient A, B, and C. Find out first deviation on each heading. Complete this table in your register. And just recheck, I have given you one of the answers. Deviation at heading 089 magnetic will be -3. Check in the table that you have prepared. Is it -3 or not? If not, then you're making a mistake. Remember, deviation will be CDM. And then good old formulas, coefficient B is deviation on heading east minus deviation on heading west divided by 2. C is deviation on heading north minus deviation on heading south by 2. And A is deviation on all these headings. Add them up algebraically and then divide it by the number of headings and you will get coefficient A. Right. Question number 4. I have given you this question bank which I have given you, or these questions which I have given you are the sample questions. You can then add them on from various other books. Only thing it will help you is that now you will not be struggling with the questions from the other books. With this knowledge, you should be able to solve it and get the answer right. And that's what I want you to do. And then you'll get it right in your examinations also. Next is question number 4. This is deals with the Earth's magnetism. That over the magnetic equator, value of H is maximum at magnetic equator and there is no dip. H is maximum and value of Z, vertical component, is 0. At the pole, value of H is 0 and Z is maximum. The angle of dip is 90 degrees at the pole. Angle of dip at equator is 0 degrees because both the North Pole and the South Pole are applying equal force on you and the needle will not dip. So use these formulas which we have done earlier. And now what else do you require? Put in these values which you have and you will be able to get the values of Z and T. And angle of dip in this question is 40 degrees. Z is T sine theta, theta is 40, H is T cosine theta, and Z by H is Z by H is equal to tan theta. Now for question number 5. I may first like to explain you Now, what are the turning and acceleration errors? Although it's theory, you would have learned in that. I will just help you to revise the theory so that you can get this question. Let me clear the screen for you. And then we will understand what are the turning and acceleration errors in a direct reading compass, direct reading magnetic compass called DRMC, also called DIC, direct indicating compass. Some of the brands available and fitted in your aircraft are E2A, P12, etc., etc. Like, let me just tell you what are the turning and acceleration errors of a direct reading magnetic compass, DRMC. The compass is fitted in front of the pilot, where you can read your readings on a line that is called lubber line. So these are the readings. And there is a line called lubber line against which you read your readings. This lubber line is not painted, but a thin wire which can be moved to left, right to adjust for coefficient A. Okay, what are the turning and acceleration error and what are they due to? That is due to the angle of dip. In the northern hemisphere, due to the angle of dip, your point of pivot moves ahead and the center of gravity lags behind. Center of gravity. And it is closer to the North Pole, point of pivot. In the southern hemisphere, point of pivot will be closer to the South Pole and center of gravity will lag behind. In both cases, center of gravity is towards equator. Because they do not lie over each other, whenever there is a disturbance on the needle during a turn or acceleration, there is a force set up at the point of pivot. Let's say you're in the northern hemisphere and you accelerate in the direction east. This point of pivot will move east. That is the point at which the needle moves. And the center of gravity will try to resist. These two forces will put up a force and your needle will be deflected to the right. Since your reference point has moved clockwise, your reading of your aircraft compass will reduce. Compass readings are always from the magnetic north indicated by this needle. So if this is my reference point, since the direction is measured clockwise, if this reference point moves clockwise, readings will decrease. Now this angle is smaller. If reference point moves anti-clockwise, readings will increase. And this reference point, the aircraft has not moved. Aircraft is in the same direction. But because of the movement of the reference point, your magnetic compass readings will change, giving us, this is one full lesson, so I'll be able to spend limited time with you so that I can concentrate on how to solve these numericals. Remember, your acceleration error is maximum on heading east and heading west. Aircraft is in the heading east or west, and this is of course north, and this is south. 180 direction, north 000 or 360, and this is west direction. If the aircraft accelerates in direction east, the needle will also move towards east and your readings will decrease. And when your readings decrease, it will give you a feeling that you have started turning towards left. Okay? Because your reference point has now moved this side. If you accelerate on heading west, the needle will move towards west and your readings will increase. Increasing means what? Towards 360 from 270. From 090, readings will decrease. Or I can say, during an acceleration, a magnetic compass gives you apparent turn towards nearer pole. Apparent turn towards nearer pole. In northern hemisphere, it shows you apparent turn towards 360. And in the southern hemisphere, it will show you apparent turn towards 180, south. 270 to 180. I can write down here, readings will decrease. And here is 090, a turn towards south. We can say readings will increase. And the common word is, during an acceleration, which is error is maximum on heading east and west, the needle indicates an apparent turn towards near pole. In the northern hemisphere, north pole, southern hemisphere, south pole, and in a deceleration, opposite will happen. Find out what will happen in acceleration and give the reverse answer. That is your acceleration error. And read it once again from your theory. I have maybe gone a little fast, but because I'm considering now the main thrust of my lesson is towards numericals, where people find a lot of difficulty. Turning error is maximum on when the aircraft is turning through the heading north, this turn, or turning through the heading south, 180. Means you are turning from 200 to 160, or 160 to 200, you will be passing through south. And if you turn from 300 to 040, you will be passing through the heading north, 000, or if you turn left. Now you see, whichever is your hemisphere, if you are in the northern hemisphere and you are turning through north means heading of 000, your compass will be sluggish or slow. So if you have to turn from 340 2050, compass is slow, and if the error is 10 degrees, you roll out at 040 itself. You will roll out early. If you are turning like this, here the reading is 040 instead of 050. You will roll out early. Compass is sluggish. By the time you roll out, then it will settle down at 050. If you are turning left, rolling out early, 10 degrees early, a direction will be 350. Now here the direction is more, here the direction is less. So point to remember is, don't go by early or late and define it from the point of rolling out. When the compass is sluggish or slow, total turn should be less. So if you have to turn by 80 degrees, if turning error is 20 degrees, turn only by 60 degrees. And from your current heading, to find out what will be the heading on which you should roll out, okay, if you are turning left, readings will decrease, turning right, readings will increase. Apply that logic. Northern hemisphere, and if I'm turning through the heading south, compass will be lively, running fast. So increase your turn or overshoot your turn by the amount of, so if you turn by 80 degrees and turning error is 30 degrees, then turn by a total amount of 110 degrees when turning through heading 180, either left or right. And that will now find out, should I turn more or less northern hemisphere? Turning through north, compass will be sluggish. And turning through heading south, compass will be lively. Southern hemisphere, turning through south, compass will be sluggish. And turning through north, compass will be lively. Whenever compass is lively, increase your amount of turn. Compass is sluggish, reduce your rate of turn, and then find out what is the total turn and apply it to your starting heading. From where are you starting? Remember, when you're turning right, readings will increase, and when you're turning left, compass readings will decrease. Now here, turning port by 90 degrees from heading 220 over Nagpur. Nagpur happens to be in the northern hemisphere. He is turning from the heading of 220. He is in the northern hemisphere. From 220, he is turning left. This is left. This is the eta. And this is his left. Under normal circumstances, if he is turning on a gyro, after turn through 90 degrees, he will roll out on 130. Here, since you have a turning error, what should be your rollout heading? Apply this knowledge and get your answer. I don't want to feed you with the answer. Must put in your own effort. Okay. So when you are going for the examination, your own effort will count. Okay. And don't send somebody else for your examination. Okay. If he gets arrested and you too, you won't be the first one. Do not try any shortcuts in aviation. Be honest to yourself. Appear in every exam properly. Okay. And remember, you are a pilot and not the so-called Munna Bhai. Good luck. All the best. Do these numericals like I've been telling you. First, do these numericals. First, do all these numericals on your own. Then come back to these hints which I have given you, and then read the answers. Have I got the correct answer or not? And wherever you have the wrong answer, I've been telling you before, give it a star. If you do it wrong twice, 2 star. And repeat these questions as many times as I can. How can I stop you? If you want to do it 3 times, 4 times, go ahead and do it. Who is stopping you? And every time you repeat a question, your speed will become better, your knowledge will become better, and you will take much lesser time. The formulas and the equations will come to your mind very fast. You can't afford to struggle in your actual examinations. And do share this video with your friends. If you are benefiting, let them also benefit. And you're welcome to give me the comments. If you feel there is something where I can improve, do let me know. Like I told you, I'm still learning. Okay. Good luck. All the best and happy landings.